Hi everyone. In this video, we will interpret results of a hypothesis test using the critical value approach. A pharmaceutical company wants to test if a new drug alters the average recovery time from a common illness, which is known to be 14 days. They conduct a study with a sample of 45 patients using the new drug. Given the null hypothesis is the mean, or mu, equals 14, and the alternative hypothesis, where mu does not equal 14, with a significance level of alpha equals 0.02, the test statistic is z equals negative 2.37, and the critical values are z sub 0.01 equals negative 2.326, and z sub 0.99 equals 2.326. Conclude whether to reject or not reject the null hypothesis and interpret the results. The first thing I want to do is look at the hypotheses that were so graciously given to us. We don't have to figure those out. The null equals 14, and the alternative, which tells us what type of test we are going to use, does not equal 14. And it is much easier to visualize this if we draw out our normal curve. And when we have a test that is not equal to, this means that we have a two-tailed test, because there are two ways to not equal the mean, and that means higher or lower. So 1, 2. We also were given that the average is accepted, that mu equals 14, and we're testing against that claim. We also have an alpha, or significance level, of 0.02. Now that includes the area under the curve for both tails, this one and this one. And because both of those together make the alpha, we need to divide that by 2 so that we get how much is on each tail. So this is alpha divided by 2, which equals 0.01. And because it's symmetric, because it's a normal curve, the tail on the right will also be 0.01. However, if we're talking about the area to the left of this tail, we can take 1 and subtract 0.01, which gives us 0.99. And that is why we have z sub 0.99. Now let's go ahead and find our critical values. The critical values are where we have our cutoff into the rejection region. So over here will be the rejection region, and over here is the rejection region. In the middle is our fail to reject region. Now let's go ahead and graph where our test statistic, the z equals negative 2.37. In this case, that means we are moving to the left of our mean. So we are 2.37 standard deviations below the mean. So we have 1 standard deviation below, 2 standard deviations below, and our critical value here, we already graphed, is negative 2.326. And our z-score for our test statistic is negative 2.37. So we're a little closer to the negative 2.5. So here's our z at negative 2.37, which puts us into the rejection zone. So that helps us decide our conclusion that we reject the null. And that means there's sufficient evidence to conclude the alternative. We've now answered both of our questions about whether we reject or not reject the null, and we've interpreted those results that there's sufficient evidence to support the claim that the new drug does, in fact, alter the recovery time. And we're all done.